So you can see we have two equations here. They are quadratic equations, and we want to solve each of them. In number one, what we're going to try to do is we're going to try to use factoring to solve our equation. So we're going to do the AC method. So we're going to do 2 times negative 21, which gives us negative 42. So I need to find a pair of factors of negative 42 that will add up to 11, because my B value in the equation is 11. 3 and 14 are going to be my choices, and I want the 3 to be negative, so negative 3 plus 14 will add up to 11. Now I'm going to use the factor by grouping method, where I turn the trinomial into a 4-term polynomial, and then I split it down the middle. 2x squared plus 14x, they have a GCF of 2x, leaves behind x plus 7. And then minus 3x minus 21, they have a GCF of negative 3. And then after the sign change, you can see it also leaves behind an x plus 7. So the 2x minus 3 make up one of my binomials, and x plus 7 is the binomial that matches. So my factored form is 2x minus 3 times x plus 7. This gives me two solutions, x equals positive 3/2 or x equals negative 7. Let's take a look at number 2. I also want to try to use factoring for number 2, but I'm going to put a question mark there, because if you're already looking at the problem, you might wonder how we're going to use factoring. If I do the AC method, I'm doing 1 times negative 6, and then I need factors of negative 6 that add up to 4. I don't really see any possibilities here. So what that means is that I have a prime trinomial. That means I cannot factor x squared plus 4x minus 6. So what do? How do I solve this equation? Well, up until now, we don't have a method other than looking at the graph and seeing what the x-intercepts are. So let's look at the graph just to remind us that there still are two x-intercepts, but we're going to need another method to solve it algebraically. All right, let's look at the images of these graphs. Okay, here's the first graph. This was the one where we were able to factor. So notice how we have two x-intercepts. There's one at negative 7, 0. And if you remember on the page before, when we got our solutions, it was because one of our solutions was x equals negative 7. So that's why our first horizontal intercept is negative 7, 0. Now, if you also remember, we got a solution of positive 3/2. That's the same as 1.5. So you can see our two x-intercepts. All right, let's now look at the graph of the other parabola. Okay, so now you'll notice we still have two x-intercepts, but look at them. Negative 5.162, 1.162, and what you don't realize, but now I'm going to tell you, is that those numbers have been rounded just so we could fit the ordered pair on the graph. So in the first graph where we were able to factor, we had what were called rational solutions. They were rational solutions because they were numbers like integers, like negative 7, or they were numbers that can be written as a fraction, like 3/2. But in the second equation, we still have two x-intercepts, but we weren't able to find them by factoring. And the reason is because we have irrational solutions. That means they're not integers, they're not fractions. Like I said, these decimals have been rounded, so those decimals will keep going, but there's no pattern, they're not repeating decimals, they're not terminating decimals, they just keep going. And the only way to write them down so you can put them in an ordered pair is to round them or to cut them off. But those are called irrational solutions. When you generate irrational solutions, it's because you started with a prime trinomial that was not able to be factored. We're going to look more at these two different types of solutions further in the unit, but I challenge you right now just to make for yourself, just to have a better idea of what these two words mean, go ahead and Google them. Look up rational numbers versus irrational numbers, because they're going to come up a lot in this unit.